the first webinar of the CIRCULAIR project. So it's the first webinar of a series of webinars that we are planning from this European Union project. The agenda for today has two presentations. So the first presentation will come from my side. I'm Valentin Batteiger of Bauhaus Luftfahrt. I'm also the coordinator of the CIRCULAIR project, and what I will provide during the first about 20 minutes is a CIRCULAIR project overview about prospects for jet fuel production from abundant agricultural residues. And then we have an external speaker, Oskar Meijerink of SkyNRG, providing a presentation on 15 years of SAF development at SkyNRG, the opportunity for advanced biofuels and e-SAF. And Oskar is also serving in the advisory group that we have for the CIRCULAIR project. After these about 20 minutes each presentations, we will have another 20 minutes for questions, answers, and discussions. And for this, we appreciate your contributions, and you can do contributions from two sides. So on one hand side, you can ask questions via the chat during the presentations, and we will try to pick up with these questions after the presentations. But you could also, after the presentations, just raise your hands with the raising hands button, and then you can unmute and directly ask questions to Oskar and me. And as I said, this is going to be now the first webinar of a series of webinars. So we will have upcoming webinars that are then deeper dives into key aspects and relevant projects results also. And you can follow us via the website, via LinkedIn to get information about this event, but also about other events of the CIRCULAIR project. Okay, so having said this short introduction, I start with my presentation, which is the project overview over the CIRCULAIR project. And I have two slides for introduction to kind of set a little bit the scope of what we are doing and why we are doing it. So this shows a rough picture of global aviation fuel consumption in relation to other important commodity products here. So aviation fuels currently are about 8% of the global crude oil refining output, and aviation fuels together with diesel are the largest share of what is called the middle distillates. And especially in this field where aviation fuels, diesel, and also marine diesel are, there is a severe limitation for renewable fuels that are currently mainly produced from lipids and waste lipids. So what we see in the future, if we want to decarbonize these various sectors that currently are fueled from the middle distillate markets, we clearly see an additional need for additional pathways. So two things, essentially, on one hand side, biofuels, then from more scalable and advanced feedstock, and also synthetic fuels from green hydrogen and CO2 sources. And both things are kind of addressed in the CIRCULAIR project. One more slide on the environment. So this is, in a nutshell, the current regulations that are there in Europe for advanced biofuels, and Oskar will also provide a little bit more detail on this in his presentation. One thing that is the bigger thing in terms of volume is Refuel EU Aviation. In Refuel EU Aviation, we have started with a 2% minimum blending mandate January this year, and everybody I'm meeting expects that these early 2% quota will now mainly be met by heifer fuels or co-processing of the same kind of feedstock. So this is Annex 9 lipids, so to say. Then afterwards, and especially after 2035, when the minimum blending mandates jumps beyond 20%, we will have renewable jet fuel demand beyond 10 megatons per year from 2035 on. And this is where we then really see a need for advanced biofuels and these RFNBOs that are produced from green hydrogen. One small point, in Refuel EU Aviation, there is no buyout, so you need to fulfill these minimum blending mandates. So if you are not fulfilling them, then you need to fulfill this afterwards, and in addition, pay a significant fine. The UK SAF mandate works a little bit different, so it's also a quota and mandate scheme, a little bit at a lower level, but in 2030 at a higher level, afterwards 2040 at a lower level. And what's interesting here is that they also have a sub-mandate for PTL, but they also have a cap on HEFA. And if you look at it, for instance, now for these figures here in 2030, you see that the total 10% mandate and these 8% and the PTL sub-mandate, these things don't add up to 10. So there is some room that can be then fulfilled with biofuels other than HEFA. And this is where, again, advanced biofuels could come in here in this scheme. Okay, but now I come very specifically to what we are doing in CIRCULAIR and what CIRCULAIR is. It's an Horizon Europe project that aims at the demonstration of the production of jet fuel and methanol and further products from manures and straw via hydrothermal liquefaction as a core technology. And in this collaborative research and development project, 10 partners combine as a consortium, and we are trying to implement and demonstrate important technologies that are building blocks of this fuel production scheme that you are seeing here. And I'm going a little bit through this scheme to give you a feeling what it's about. So we start with feedstock that is abundant in agriculture, manure and straw. Then there is HTL coupled with wet oxidation. I will explain why as the core technology. Then there is a biocrude that is upgraded to fuel products. Along that pathways, we have CO2 streams that evolve. These CO2 streams are then utilized by green hydrogen to increase the overall carbon utilization of the pathways. And then there is additional byproducts from other phases that we also try to utilize. So this is the thing. And what is important here is to show that when we talk about hydrothermal liquefaction, that there is already commercialization going on that is reaching beyond our current project in terms of technological readiness and scale. So this is a little bit the roadmap that we are having. So we were starting building a lot on preceding Horizon 2020 projects, where one example is HyFlex Fuel, where our project partners, Aarhus University, was running a pilot plan. Then there is another project partner of us, CIRCULAIR Nordic, that is already going into upscale at higher technology readiness level and larger scale with a very specific business model. And we at CIRCULAIR, we are, so to say, preparing the next wave, looking at a very holistic thing and also developing additional technologies that can be important for this thing to bring it into the system then, so to say, in the next wave of commercialization. So what is the ambition beyond the state of the art in HTL in this project? And one important thing here is this set integration of HTL with wet oxidation of the HTL process water. And what is relating to this is the recovery of suitable byproducts from all major process streams. So this is, so to say, roughly a state-of-the-art carbon balance, where you see that a lot of the carbon goes in the aqueous phase that results from hydrothermal liquefaction. And the idea is now to do this wet oxidation of this aqueous phase. So this provides heat to the process. The organic species are mainly then converted into CO2 and volatile fatty acids that are then still in the process water and could be recovered. And the CO2 can then be combined with hydrogen to form methanol. So this is the big chunk, so to say, to get a much higher carbon efficiency of the overall process. And then we also look at the CO2-rich HTL gas, utilization of the solids and so on to get to a very high product fraction at the end of the day. And we also look at the upgrading of the biocrude here in this project. And here we want to fulfill the jet fuel specifications, but we would also like to have a kerosene fraction that is as large as possible. And here we do additional things, especially to this bottom residue. So this is a little bit how we want to reach beyond the state of art. And this translates also now into four main objectives that we have in the project. So we want to contribute to the development of cost-effective pathways to biofuel production from abundant feedstock. We want to produce this high share of on-specification jet fuel from HTL biocrudes. We want to prepare for near complete biomass utilization, and I have not really mentioned that before. We also want to enable negative contributions to the greenhouse gas balance of HTL fuel production. And this is mainly here in this project and via the solids. Okay, one word on the feedstocks. So why are we looking at the manures and straws? So this relates back to the HyFlex fuel project that was the preceding project where former project partner DBFZ was analyzing residue and waste availabilities in Europe. And the result was really that the big pieces of this cake are the manures and are the straws, and they are really then available at the scale of 100 megatons dry matter. So, so this is really something that could potentially provide us then also with large fuel volumes. And when you compare, for instance, here to sewage sludge, which is maybe very favorable for more early business cases of HTL conversion, it's just a lot more volume that we could get into the system via manures and straws here. Now, this is one hand, so the abundance of the feedstock. The other thing is this potentially cost-effective pathways. So cost efficiency comes from HTL itself, which is increasingly perceived as a prime option for wet waste conversion of biofuels because we don't have the need to dry the feedstock. We work with an aqueous slurry here. But one thing that results from this way of hydrothermal conversion is the process water, and this is challenging to deal with. So the process water looks like this. It has a high chemical oxygen demand, so it needs to be kind of cleared up. And what the wet oxidation could do there is to reduce the so-called chemical oxygen demand, which is a measure for the organic content here of the HTL process water, clean it up, provide heat to the HTL process itself, and thereby remove, so to say, also the demand for external process heat here, and thereby maybe go to an autothermal process that has then lower operation costs at the end of the day. Next target, high share of on-specification jet fuel from HTL biocrude. The pictures that you see here and also these measurement results are again still from the preceding project, HyFlex fuel, where former partner and current partner Aalborg University was demonstrating that it's possible to convert these biocrudes, these viscous black biocrudes that result from hydrothermal liquefaction, into something that is an on-specification jet fuel, not yet approved, but that resembles the properties of the current jet fuels in many, or let's say almost all aspects. And this is, so to say, this pathways that we again want to demonstrate here for the specific biocrudes that we are producing. In parallel, we look at slurry upgrading as an let's say, alternative or amending technology to fixed bed hydrotreating, and we investigate this hydrocracking here as well in order to, at the end of the day, then really have a higher share of the jet fuel product. Next thing is the utilization of co-products from all of the major streams that result from hydrothermal liquefaction. And this is when we look at the process water from wet oxidation, mainly volatile fatty acids with a high share of acetic acid that could be recovered via liquid extraction or via adsorption, and also the ammonia could be recovered via adsorption, potentially using HTL solids here, so preserving some of the fertilizing effect. Then the next big thing is the CO2 streams. So both the HTL and wet oxidation gas contain mainly CO2. So it's more than 90% in these streams. And when we recover it and clean it up sufficiently, then we can use it, for instance, for methanol synthesis using green hydrogen, so with a coupling to the power-to-X world. And the last big thing is the utilization of the HTL solids. Here it's about analyzing what these solids are, how we can modify these solids such that they are suitable for soil amendment and carbon sequestration via this amendment of the soils. So this is the third target, and the fourth one is carbon negativity, and this relates to the system analysis that we at Bauhaus Luftfahrt are contributing to the project. And here I show some preliminary results that stem from a two-step approach that we have in the project for the system analysis. So one is that we have an initial modeling of the fuel pathway pretty early in the project, and then start with a first evaluation of fuel production costs and LCA. And this is something that some step that we have just finished, and where you now see the preliminary results. And then in the next step, in the second half of the project, we will go into refined modeling, and at a later stage of the project, we will then have the final system analysis results available. So what you see here today in these presentations are these preliminary results from this first evaluation. And in terms of LCA, we see an 84% reduction in global warming potential compared here to a jet fuel reference. This would already be compliant with the EU Renewable Energy Directive, which for biofuels foresees a minimum of 65% reduction. One has to say that it's as good as 84% reduction, because we are utilizing renewable heat here that comes from this wet oxidation, and we also utilize mainly renewable hydrogen for the upgrading and also for the methanol synthesis. So this is the key here. And also one may expect that this result of the fuel mix is somewhat improved also by the green methanol that may a little bit improve the result of the fuel mix. But in any way, this 84% is a nice signal in first place, but it's not yet at target with what we want to show in CIRCULAIR, which is negative contributions to the greenhouse gas balance. But here we have not yet implemented some of the main levers that we have. So what are the main levers to achieve these negative contributions? So one is the HTL solids for carbon sequestration. So this is in this other analysis, but it's not yet a good value that we have here. So here, University of Hohenheim is currently investigating the utilization of stabilized HTL biochars for soil amendment in agriculture, and they will also evaluate the carbon sequestration potential, and that this evaluation will then go into the final results that we will have. What we have also not implemented is a credit for a change in manure handling practice. So this is something that is known and shown on the right-hand side, that you have currently very significant emissions in the agricultural sector that result mainly from the manure storage. And if we now change this by constantly consuming these manures, we can have avoided emission credit on the balancing sheet. And this is something that could also, again, on the balancing sheet then lead to an overall negative contribution if you just give this credit to the fuel production. Further options would, of course, be that if you kind of capture these CO2 streams that evolve and sequester them instead of utilization, then this is another handle that you have to go negative. Now, last slide from my side in terms of contents, it's the first preliminary techno-economic result. So we also evaluated a production cost estimate for this mix of fuel products. So this mix contains all these HTL fuel products and methanol on a heating value basis. And the preliminary result is 99 euro per megawatt hour, using a rather high, I would say, near-term capex estimate for HTL wet oxidation. And if we go in with a much lower, maybe a little bit too low capex estimate for the long term, then we are somewhere around 60 euro per megawatt hour. And what I have shown here as two lines for comparison is the current jet fuel price, and this up here is some reference value for aviation biofuels. So mainly this should be HEFA that is provided by EASA in the current report to estimate the fines for refuel EU aviation. And what you see here is a jet fuel production price that is here somewhere in between. So this is certainly something that looks promising now from this early perspective. Summary and conclusion. So at the beginning, I motivated that we need liquid fuels to achieve the climate targets in aviation and in shipping. And very specifically, we have a specific need here for scalable fuels from advanced biomass, wind and solar. And this then also introduces the next presentation by Oskar, where this will be a key topic. Now, the circular perspective, we are aiming really at HTL conversion of abundant agricultural residues that could really provide large volumes of fuel. One important thing is that we address the HTL process water challenge by wet oxidation. We want to maximize jet fuel yield and quality by appropriate upgrading schemes, then enable almost complete feedstock utilization by coupling with green hydrogen and recovery of products from almost all process streams. And we want to investigate the use of HTL solids for soil amendment and carbon sequestration. So this is are the main aims of the project. And what I have shown towards the end is that pre-evaluation of fuel production costs and global warming potential kind of fosters our motivation that we have in the project, and it also points to some main levers for further improvement. And we are not going to have question and answers now to my presentation, so we will directly go to Oskar's presentation now, and afterwards you will have the opportunity to ask questions to my presentation and also Oskar's presentation. So Oskar, it's your floor.
Thanks, Valentin. That's much appreciated. Let me quickly share my screen. This should work now. Yes, there we go. So nice to meet you all. My name is Oskar Meijerink. I'm the head of Future Fuels at SkyNRG. We're in the space of sustainable aviation fuel, and I've got a very long relationship with Valentin already, so very happy to be part of the advisory group of this project, and happy to talk a little bit about SAF today, a small piece about SkyNRG for the ones that don't know us, and then spend most of the 15 to 20 minutes on the last piece, which is the market development side and the opportunity for advanced biomass, and specifically the fuel that could be used by this circular project, obviously. So people new to the space, we see that aviation is a growing industry. We had our hiccup during COVID, but we're now well beyond the 2019 levels again, and growing and expected to grow quite significantly still for the next decades. And while the aviation industry is only about 2 to 3% of global emissions today, the expectation is that this will double towards 2050, and then we'll have a lot bigger impact of over 20% of global emissions in 2050. So we need to do something about that, and we see that sustainable aviation fuel is basically the only alternative for a very big portion of the emissions. So what you see on the left-hand side is always quite an interesting element to show, because about 75% of the global fleet and flights is short range flights, but those only account for about a quarter of the emissions. So you see that the medium and the long range flights account for over almost 75% of the emissions, which are also the most difficult to decarbonize emissions. So for some of those short flights, we see battery electric and some hydrogen combustion potential. But for these medium and long range flights, that's very challenging. And so for that, we are eyeing sustainable aviation fuel as a solution for the decarbonization of aviation. And then we have this slide. This may be known to many. We basically set as an industry a net zero target in 2050. And to achieve that, we need to do a number of things, right? The first and the easiest is always, or well, maybe not the easiest, but the most logical one is don't fly, because then we're not growing this industry. But we do recognize that there will be an aviation industry, obviously, and that industry will also grow somewhat. So then there's a couple of things you can do. We can still become more efficient, which we call the efficiency improvements, with straighter line flights, for example. We now have quite some inefficiencies in the flight network. There are new propulsion technologies that can contribute, and then a very big portion should and is forecasted to come from sustainable aviation fuel. And there is always some residual emissions that then need to be offset with, for example, carbon removal credits or other offset schemes. With that in mind, we can see that sustainable aviation fuel can be produced by a number of pathways. So you may have seen many of those. We always say and like to say that SAF can be made from 3 buckets of feedstock. So on the one hand, and that's the dominant pathway today, is from waste oils and fats. So that's what we call the HEFA pathway, for example. It's waste oils, used cooking oil, residues from animal fats, for example. The upside is that technology is very well proven. It works well. There's facilities out there. There's renewable diesel. There's SAF production. But the limitations are obviously around the feedstock availability. And we'll come back to that in a few slides. But the upside is that it works. It's ASTM certified. So that means that it can be used in commercial aviation, and is happening today. The second bucket of feedstock is biomass. And that's also obviously where the CIRCULAIR project fits in. And then you have a number of routes. So you can go through sugars or alcohol to SAF, but you can also go like an HTL type pathway that Valentin just showed. So that's the bottom one. And what is good to note is that pathway still requires ASTM certification. So that means, or qualification, I should actually say. That means that the pathway still needs to be approved for use in commercial aviation, and specifically with HTO and pyrolysis type pathways. That's somewhat of a challenge because the composition of the fuel can be quite different. So it's more difficult than maybe some other pathways to get it very consistent at the same specification. So there's a lot of work ongoing on the ASTM side to get this done. The big upside is obviously there's a lot more feedstock available, and there's a lot more scalability potential in this pathway. And then the final one is the e-SAF pathway, or the power to liquids pathway, where you use CO2 and renewable hydrogen and can use that in the pathway. It shows that it is not yet ASTM certified, or it shows a cross there. That's a little bit, that depends a bit on the pathway. If you're using a Fischer-Tropsch pathway, it is actually qualified. So some new pathways may need ASTM qualification, but many are already qualified. So that's not entirely the case. So that's good to note on this slide. With that bit of an intro on sustainable aviation fuel, and happy to take any questions in general on that. Very quickly on SkyNRG, we've been in this market for 15 years. So we've been founded in 2009, and the first, let's say, 10 years or so, we're focused on creating the market for sustainable aviation fuel. So we've done a lot of the initial flights, the first commercial flight together with KLM, the initial corporate biofuel program where we allowed for corporate passengers to fly on SAF, but also the first, let's say, continuous supply chains in the US, for example. Since 2019, we started to develop our own production capacity, and we're working on that together with our partners like Boeing, KLM, but also our recent investor, Macquarie Asset Management, that stepped in 2023. We're now focusing on activities across the value chain. So we're both on the R&D side, active in projects like CIRCULAIR to understand what is out there, what technologies work, which pathways we could use in our future projects, as well as the capacity development and the production side, where we then aiming to actually build those facilities and obviously operate them. And finally sell the fuel and supply that to the airports. We do some advisory work across that network as well, because we have built that expertise and sell that to clients that are interested in learning more about the SAF topic. We currently have 3 main projects in our pipeline. Those are the 3 projects that you see here. So from basically right to left, which is a bit counterintuitive, but that's because that's the most advanced project, is our project in Delfzijl in the Netherlands. That's a HEFA project, about 100,000 tons output, which will be operational in the 2028 time frame when we start the construction this year. The offtake is secured by KLM, and SHV is responsible for some of our byproducts, and we achieve obviously very good greenhouse gas results. Then we have 2 other projects in our pipeline that use different pathways. So we have a renewable natural gas to SAF project based on advanced feedstocks in the US, where we're aiming to do about 50 million gallons of SAF. Boeing is one of our partners and offtake partners in that project. And then we have an e-SAF project in the north of Europe, where we're focusing on using CO2 and hydrogen. So we have projects across the various types of SAF, and we're aiming to scale those and replicate those models in other jurisdictions as well. The reason for focusing on SAF is that there is very limited options for the aviation industry to decarbonize, as I showed in the beginning of this presentation, but also because there's quite a strong market pool and support from policy side. So the Refuel EU mandate kicked in this year in 2025 and is the main driver for SAF in Europe. So you see on the bottom left a number of the percentages and the increase over time. And what is good to note that there is a very specific sub-mandate for e-SAF, and all the other types of SAF are bundled in, let's say, the rest of the targets. And there's a very significant penalty for non-compliance. That creates a driver for SAF, but it also means, because there's no sub-mandate per se for advanced biofuels, that you're competing against other pathways like the HEFA pathway until there is a limitation on the feedstock availability there. What you also can see is based on the notes that Valentin made before, that animal manure, but also straw residues are part of what we call Part A of Annex 9 of this piece of legislation, and that allows for a higher value and therefore a better accepted fuel, so what we call advanced biofuels. So that's very interesting, because that's quite hard to make. So if you have a technology that can use these feedstocks, that's a big upside. Feedstocks that are excluded are food and feed type crops, soy and palm derivatives, as well, based on the potential indirect impacts those might have. In a number of other jurisdictions, we also see mandates and targets developing. In the US, there's a number of very specific states. So California, for example, but also Washington State and some of the states in the Midwest have announced quite strong targets and incentives but also on the other side, Indonesia and Japan and India and also China are discussing and proposing legislation and policies to stimulate the use of SAF and the production of SAF as well. We then, every year we make a market outlook that is coming out in June. So we're very happy to announce that on the 5th of June, we're releasing our new market outlook. If you're interested, then don't hesitate to send me an email, but we will announce that and we will publish our new report. So this graph will be updated on that date. But what we're there doing is basically assessing the amount of announced production projects and production capacity divided by technology. So what you see here is a worldwide view, a global view up till 2030, where we see that over time the amount of capacity is increased to about 17.3 million tons of SAF capacity. The vast majority of that, so 85%, is HEFA-based capacity. So we're still very much dominated by that pathway, although some of these other pathways like alcohol to jet, specifically in the US based on corn ethanol, as well as some in Brazil and India are taking a position. You see some of these smaller green lines, that is what we call bio Fischer-Tropsch or bio alcohol to jet. Those are announced projects that are more using advanced biomass as a feedstock. And the project that we've been discussing today would also fit in those greener categories, but just as a new pathway because it's HTL or pyrolysis pathway, as we explained in the beginning. If we then take a further look beyond 2030, we here have plotted basically the demand for SAF in the dark gray background and then a dotted gray background of what that IATA net zero target should be if you want to fulfill that 63% that we plotted all the way in the beginning of this presentation, and what these other pathways could contribute to that. So we've restricted some of that growth based on ability to produce new facilities, but also what we believe could be feasible from a feedstock allocation point of view towards the aviation industry. And then you see a number of interesting facts. So one is we're very reliant on the import of waste oils and fats in the EU, but also that we see that industry and specifically the HEFA pathway is constrained to 40 million ton by 2050 because we don't see any more, let's say, waste oils available. It's somewhat growing, also because of the potential cover crops, for example, but the growth for that HEFA pathway is relatively restricted. And therefore, we see that the growth from the, let's say, SAF for the SAF industry is mostly coming from the advanced bio pathway, as well as the e-SAF pathway in yellow. So this project is very important because it unlocks a technology that can fulfill this advanced bio portion in green, which we very much need to achieve our net zero targets. We have somewhat constrained that in this assessment based on the available biomass, but we do believe in the 2025 assessment we've updated this work as I mentioned. We see actually there's quite a bit more potential actually on the advanced biomass side. Once policy comes in to stimulate that, there's actually a lot of feedstock available to fulfill these targets. So even with that is possible, this is the final slide, we do still see that we need somewhat more than just the mandates in a European context. So we also need support from both demand as well as market and supply side. And we've listed a number of ways to stimulate this industry, right? It all comes down to investor confidence and ability to finance these projects against a market that is stable. So on the one hand, you have the market. We need specific sub-mandates to potentially stimulate these advanced bio pathways already today against the HEFA market that is there leading at the moment. But for that growth to take place, we need these alternative pathways as well. And from a supply side, it's very important to create financial instruments to support also the offtake side. And that's not only a subsidy, but can also be guarantees, for example, or a contract for difference approach that once the market may not be as high in a certain year, that there's a mechanism to solve for that. And that will create a lot of confidence in the market and therefore investments to flow in. And finally, there is a need to support on the airline side. And one of the elements that are being used now is the extension of the EU ETS allowances to be used for SAF use. And that's quite an elegant way to recover some of the price premium that exists on SAF, because that's not a topic that we've discussed in a lot of detail, but obviously these fuels are more expensive than fossil jet fuel. So you need mechanisms to solve for that. So very quick overview, but hopefully it gave a bit of insights, and feel free to ask any questions that you may have.
Thank you, Oskar, for this presentation. I liked it a lot. So we have 2 questions in the chat. I would suppose that I'm addressing these questions now, and then maybe we can start with discussions and questions by attendees raising their hands.
Of course.
And we can see how this goes. So there is one question. It's not a question, it's a comment by Ulf Neuling. He just wanted to really point out that, of course, power to liquids via the HEFA pathway is approved. Yes. And I know exactly that Ulf knows this, so I don't think that this was a real question.
Sorry, there was probably a bit of a mistake in the slide, but it depends a bit on the pathway you're using. But indeed,
you said it. You said it. Just to make it clear. And
yes.
And then there was another question by Jörg Ottmeier. This was specifically on my techno-economic estimates, or let's say our techno-economic estimates here, and it was the role of the input biomass price and what is the assumption. So it's a very important question, and the assumption here was that we can use the manure for free, so 0 cost for the manure, and for the straw we assumed a typical price for the straw that you see in the literature. So the context of this evaluation, I didn't have time to show this, is Denmark here, and it has a rather big role because we see in HTL, especially for the earlier business cases where you can deal with real waste streams. So one example is soot sludge, but there's also other waste streams that need to be disposed. That in that cases you can really go to kind of negative feedstock prices, and that of course help you a lot for your overall fuel production price. And if you have now positive ones or lower ones, then it's getting a little bit more difficult. Now, one can question if 0 is the right estimate for the manures, but certainly there are regions in Europe where there is a surplus of manures and where the manures also pose kind of a disposal problem. But yeah, this is not, I would say it was not enough for us to assume negative prices here. So if there is additional questions, so please raise your hands. So far I didn't see anyone, but there is an additional question. If we are studying the biological production of the aromatic fraction of aviation fuels. So this is some discussion that is big in this sphere from many, many aspects. And my personal opinion is that the conventional jet fuel bring in more than sufficient amount of aromatics at this moment in time. Many people believe even too much and want to get them out. But with hydrothermal liquefaction, it's a direct liquefaction process. And if we do nothing to the final fuel, we will have aromatics in the fuel. So also this small chart with the fuel composition that I was showing from the HyFlex Fuel project had a few percentages of aromatics in the fuel. And then it's the question what to do with it. So one could say, okay, this is an advantage because you can then go in towards drop-in, which still has a minimum requirements of aromatics. You could also say it's a disadvantage and add another step afterwards to kind of saturate these aromatics if you eye for less air pollution, less non-CO2 climate impact at the end of the day. I hope this answers the question. Still, I don't see any hands that are raised and no new questions in the chat. So this gives maybe me a question to ask, opportunity to ask a question to Oskar, and Oskar to ask a question to me. Maybe Oskar, do you have any question to what we are doing in the project?
It's a good point. Are you on the ASTM side? Are you looking to explore already today with the design of obviously in early days of the development of a project and technology, you don't really look at ASTM directly, right? But
Yeah.
Are you already exploring ways of finding synergies with other pathways or other technologies, and considering potentially going for the fuel qualification, or is that really something you want to explore after the project is done?
I believe what we can do in the project is contributing to the discussion and contributing also to the knowledge base that later translates or helps to assist this fuel qualification process. As you were pointing out in your presentation, whether you go pyrolysis or hydrothermal liquefaction, so these direct liquefaction kind of pathways, you preserve certain, let's say, features, elements of your feedstock. So your biocrudes, the composition of your biocrudes will depend on your feedstock composition, and your composition of the final fuels will depend on your feedstock composition. And this makes it a little bit more difficult to go for these ASTM's D7566 annexes that we are used today, which have more consistent fuel pathways. Let's say it like this. And again, if you go for new feedstocks, you also have new challenges in the upgrading, and this is also something that we currently face in this project. But I believe we will come to this point where we will make a kerosene from the HTL biocrudes from manure and straw. And then our project partner Eni will do the fuel analysis and see if it's compliant with the jet fuel specification. And these things hopefully will then at the end of the day also be published, and then it can be used. But we are not going to go for fuel qualification. But if we have these materials, we will then also likely reach out to the EU clearinghouse or counterparts in the US and provide these samples such that they can also have a look how the composition is.
That makes sense.
There is a question from Doug Elliott in the chat. Doug Elliott is another member of our advisory group of CIRCULAIR, and he asks us what impacts we are seeing or expecting from the recently changed administration in the US. And I hand over this question to Oskar, as I saw a slide where there was also a facility in the US. So maybe.
Yes, that's definitely something I can. I'm not an expert, right? I'm not in the US myself. I'm based in Amsterdam in the Netherlands, so it's always from a distance. But we see, I think, as most of us in this industry see, mostly uncertainty at the moment, where there's a little bit of a wait and see approach. The biggest impact we have seen on actual project is with the let's say disallowance of importing feedstocks into the US for production. So there's a lot of there's quite some pressure on facilities of using feedstocks from inside the US when there is a US-based project. So that's one thing. On the policy side, the IRA is under pressure. So on the hydrogen side, there's definitely some movements. From a bio-based and a biomass biofuel point of view, I feel that the pressure is somewhat different, and the impact is a little bit less because and I feel that that's mostly because those incentive schemes and policy schemes are also very important for the agricultural base in the US. So a lot of these mechanisms like the RINs and the systems that are there to stimulate on the one hand ethanol markets, but also advanced biofuel markets are taking place in agricultural states, which is also obviously the support group for the Trump administration. So we see that there's some reframing of sustainability into energy security, for example, but the mechanism staying relatively the same and similarly continuing to exist. And then thirdly, I think there's quite wide support for projects inside the US. So on our project in the US, there's actually quite a lot of support in the sense that if you can develop a project in the US, then this administration is very supportive of that in the sense of new job creations and economic development, obviously. So we definitely see impacts. I don't say it's great from a sustainability point of view what's going on, but from a project point of view, it's the impact is a little bit less if you can rely on locally sourced feedstocks. Hope that answers the question a bit, Doc.
I don't think that there is an exhaustive answer to this question, but I can maybe just add with HTL, you can also do a service in the wastewater treatment world. And so I hope that at least this is something that is still of value in the US. But there's another US question from Giuliano. Giuliano, very nice to see you. So I know Giuliano from Hyflex Fuel when he was with Aarhus University. And the question is back to ASTM. If we expect several parts certified because of feed variability, or ASTM being more flexible to capture the natural variability of the feedstocks? And this is a very excellent question, and I cannot give you the answer. So I can just share a few ideas. I believe the second part of your question is where we need to go for the long term. So where we need to where we need a specification that says, okay, this HTL fuel is okay as long as it's really kind of hydrocarbons that you have in here and you're fulfilling the specifications pretty much what we currently see for the crude oil. So I think this is something that we really want to achieve in the longer term future, but this is not how these ASTM annexes work currently. So for the more near term future, it may be worth to go in first place for a specific feedstock, for maybe also a specific version of HTL conversion and upgrading to have it narrow enough such that the aviation OEMs, so turbine manufacturers, Boeing, Airbus, and so on, can accept this to have, let's say, an early approval and a showcase, and then afterwards work towards this larger dream. So these are two ideas, and I think this needs to be figured out with a multi-stakeholder approach. What is then really the best way forward there?
Fully agree.
Okay, then I don't see an additional question gives me opportunity to ask something to Oskar. So now one more thing about your presentations. You had like 5% for the co-processing, and now at least in DevStan it's 30, and maybe it's not 30 but only 15. But okay. But you also said you underestimated what co-processing could do in kind of your analysis. And my question to you is, if you have the feeling that we are maybe still thinking too too much in this single fuel pathway things where there is a HEFA pathway, where there is a PTL pathway and another pathway, and maybe we are then more aiming going into a future where plants will be built at refinery and chemical sites where it's not so clear that it's one pathway anymore, but we will bring in oils from different origin that then share hydrotreating capabilities and so on. Do you think that these, let's say, more diverse versions of co-processing is something that we could see increasingly in the future, and this is also maybe an important path into the future?
Yes, I very much see that, and that's also what we're trying to do with let's say the pathways being more feedstock pockets, right? So it's more like, even though we may underestimate co-processing of waste oils, the waste oil feedstock pocket is still restricted. So I don't really mind whether it's actually dedicated HEFA or co-processing in sort of a biorefinery concept that needs to play out over time, right? But I do think that I do stand behind the conclusion that feedstock is inherently restricted more than potentially biomass-based pathways. But I fully agree that there will be more biorefinery concepts where multiple, let's say, products or feedstocks are being treated alongside each other. Especially the hydrotreatment technology is a very logical technology for many, as a backend for many pathways, right? So it's the core technology for HEFA, but it's also very much necessary to upgrade some of these pyrolysis or HTL-like oils into a product that's then SAF. So I think that we are still now in a phase where some of these technologies need a very good proof point, and you don't want to make that proof point in too complex refinery structures, right? So it's very difficult to co-process something of which you don't know fully yet how it behaves or how it reacts in a refinery. But if we've done some of these projects in a dedicated manner for some years, you will see projects trying to combine these things to reach a bigger scale and to be able to achieve some efficiencies over time because of that combination, right? So I definitely see that. I also think that with the oil majors that will play a major role. I must say, they're a little bit absent today. It's really good to see Eni in the mix in your project. We've seen the past year too much reluctancy, to be honest, too many cancellations. So I really hope they come back to the table, because they will play a very major role in transforming some of the equipment that is there into these biorefinery concepts, where we can use existing refineries in sort of a co-processing setup, and then in a more dedicated biorefinery setup over time. So I really feel that plays a major role. So I also see a major role for some of these intermediate products like biocrudes and other veg oils.
Yeah, thank you, Oskar. Thank you also for mentioning ENI. It's very important for us that we have industrial project partners also here, like really relevant ones. So ENI and but also Topso, who's really a very key partner for us, especially with all these upgrading questions that we have been addressing now. But I have mentioned this, of course, CIRCULAIR Nordic as a startup type of company in the HTL sphere. So there is one more question, and then we are close to the end, and it is coming from Georg Eckel of DLR. This is nice, because then I can also advertise international conference of sustainable aviation research that's happening beginning of July in Dublin. Georg will be there, I will be there, and maybe you want to join as well. And on this conference, Georg, I will answer your question on the consistency of feedstock, and then you also have a comment, and maybe you can unmute and just contribute your comment to the discussion here, because I think it's really a relevant input that you can provide here.
Yeah.
You cannot unmute. Try again. Okay, Georg, can you?
Now I can.
Okay.
Yeah, I was just, my question was related to the Firefly work on HTL, and I was impressed how consistent actually the feedstock was from the sewage. That was why I was wondering. But yeah, then I'm waiting for Dublin. A nice teaser, thanks. The comment was that there's currently actually a first step towards a generic feedstock in the co-processing. So it's the first time actually the OEMs allow a generic idea to be brought forward. Yeah, let's see how that works. Small percentage, but it's in the direction you said, Valentin.
Yeah, this is perfect. This is good to know, and I think this also shows how, you know, the discussions we have there evolve over time, and how important things are then acknowledged, and also what I have the feeling often with ASTM, they are quite conservative for good reasons, because safety is so important in aviation, but they are willing to move and do something in that direction. And this is, at least from my side, well appreciated. I would say we keep it there because it's now 5 o'clock. I enjoyed it. I also thank everybody for the contributions now to the final discussions. So this was the first webinar of the CIRCULAIR project. So there will be upcoming ones. So we don't have a date yet. We don't have the topic yet, but it will be about the things that you have been seeing for the process. It's certainly going to be about HTL coupled with wet oxidation. It's certainly going to be about wet oxidations, about this utilization of byproducts, being it volatile fatty acid recovery or the HTL solids, and certainly we will have something more detailed on the techno-economics in the future, and the same thing as we had today, also some external contributions. So having said this, I thank you all for your attendance today. I hope, again, you have enjoyed it. Thank you, especially Oskar, for this contribution today to our webinar. And yeah, have a nice day. Goodbye.